In this video, we want to give the partial fraction decomposition of this rational expression. In the last video we did on this subject, we had dealt with linear factors that weren't repeated. Here we have some that are. We have one factor in the denominator, x minus 1 to the second, and x plus 1. So the technique is going to be similar in some ways and different in others. So here's the way it works. The rational expression is in proper format. The degree of the numerator is less than the degree of the denominator. And the numerator is degree 2, and this is the x minus 1 squared. It gives you an x squared, and an x is x to the third power. So the degree of the numerator is 2, the degree of the denominator is 3, so it's a proper rational expression. So the way it works is we take a constant, we're going to call it a, over, and this one's already factored out. The last one we had to factor the denominator. This would be x minus 1. Now if it didn't have any repeated factors, if this was not a square here, we would just have a constant a over x minus 1 plus another constant b over x plus 1. But because it's two powers, or second power there, we have to go again and say this is going to be plus b over x minus 1 to the second. Now at this point to the third power, then we'd have another expression, c over x minus 1 to the third, and so on. The same thing with x plus 1. If this had a power, would go x plus 1, or another constant over x plus 1, another constant over x plus 1 to the second if it had a power of 2. In that case, we'll finish with that one, and then we go plus another constant c over x plus 1 is not repeated, so it's just c over x plus 1. Now at this point, it's just like the other one we did. We multiply both sides by the least common denominator, which would be x minus 1 squared times x plus 1, and set up your system of equations. In this case, we have three variables, so we're going to have, or three constants, so we're going to have a system of three variables, a, b, and c, and we'll have to solve. And I have it over here in this format, a over x minus 1 plus b over x minus 1 squared. And now you could have put the x plus 1 over here first, so it could have been a over x plus 1, and then a b over x minus 1, and then a c over x minus 1 squared. Doesn't matter, it's always, as long as you have the correct setup, and this is it. Now at this point, then what we do is we multiply by the lowest common denominator, which is x minus 1 to the second times x plus 1. So we put it over here. When we do that, the left side will just have x squared, because the x minus 1 squared and the x plus 1 will cancel. Now I multiply both sides, every term of both sides. So when I multiply this first one by, again, multiplying by x minus 1 squared, x plus 1. So x minus 1 is going to cancel, so I'm going to have a for the first term, first expression. I'm going to have a, and then this will be x minus 1 times x plus 1. And then a plus b, and multiply again that expression by x minus 1 squared times x plus 1. So notice this has an x minus 1 squared in the denominator, so that's going to cancel. So the only thing I have left is the x plus 1 plus, and then I'll have multiplying the last expression, c over x plus 1, by the lowest common denominator. The x plus 1 will cancel, so this will give me with c, and I have left over x minus 1 squared. Okay, so then this is going to equal to, so it'll be a, and then I multiply this out, x minus 1 times x plus 1. That's difference of the sum of two terms, so that'll give me x squared minus 1 plus, and then this one I just leave it the way it is for now. It's already simplified, b times x plus 1, and then plus c, and then multiply this out, x minus 1 quantity squared. This is going to binomial, so that'll be x squared minus 2x plus 1. And then here's where we're going to collect terms. So we're going to group all the terms with an x squared. So notice I got multiply a times x squared, that gives me ax squared. And then over here, if I multiply through by I got c times x squared. So I got ax squared plus cx squared. So I'm going to group those together. So this will be a, factor out the x squared, so it'll be a plus c, or just a plus c rather, times x squared. Now let's group the ones that have an x in the expression. So b, but if I multiply this second one here by b, I have b times x, b times 1. So this will be a bx, and then over here multiplying by c here, that'll give me a minus 2c. So this will give me then a b, coefficient of x, and a minus, and those are the coefficients of x. bx here, and here if I multiply by c, it's a minus 2cx. So the coefficient is minus 2c. So it is a minus 2cx. I'm just grouping the terms with an x. So I have a bx and a minus 2cx. Factor out the x, I get that. And then the rest we can treat like a constant. So what else do we have left? Well, from the first product, a times minus 1 is a minus a. So I'll put a minus a here. And then for the second product, b times 1 will be b. And then c times 1 is c. So that's your constant. And remember, the way it works is you simply equate coefficients from one side to the other. So here I have an x squared. On the other side I have x squared. The coefficient of the x squared over here is 1. So that means that a plus c has to equal to 1. And I'm going to move up here. A plus c is equal to 1. So this is going to be a has to equal to 1. And then b minus 2c has to equal to the corresponding coefficient on the other side. So on the left side, whatever the coefficient of x is has to equal to b minus 2c. Well, there is no x there, so the coefficient is 0. So that tells me that b minus 2c has to equal to 0. And then minus a plus b plus c, that's the corresponding constant. So that has to equal to the constant on the left side of the equation here. There is no constant there, so that means it's 0. So we just say minus a plus b plus c is equal to 0. And there are other ways to work these kind of problems shorter by making substitutions for x. For example, on this first one here, where I have x squared equal to a, I could say, well, this is supposed to be an identity, so let's replace the x by 1, and this whole thing's going to cancel. We'll look at that a little bit later. Anyway, you get this system right here. So now it's a system of equations, 3 variables, a, b, and c. So we try to solve this by substitution, by elimination. So let's do this. Let's take equation 1 and 3, and let's add them up. A minus a cancels. So what does that give me? b plus 2c equal to 0. Adding equation 1 and 3, I get b plus 2c, I should say, equal to 1. Okay, 1 and 0 is 1. And then c and c is 2c. A minus a cancels. And then there's no b here to add, so it just says b. So I get b plus 2c is equal to 1. Okay, so now I need another equation that has the same variables. Well, number 2 has the same variables. So let's look at b minus 2c equal to 0. And let's solve this one by elimination. Again, there's a lot of methods to solve systems of equations. There's matrix operations, there's determinants, there's substitution method. But here, probably the easiest one in this particular case is just elimination. This is going to be 2b. Let's just set them up, because notice the c will cancel when I add them. So add them up, I get 2b. Then 1 and 0 is 1. Divide by 2. B is equal to 1/2. So b is equal to 1/2. So let's look at the first one then. Put a 1/2 where the b is. The plus 2c is equal to 1. Subtract 1/2 from both sides. We get 2c is equal to 1/2. Multiply by both sides by 1/2 to cancel the coefficient here. This will go to 1c. Multiply on the other side will give me, so multiplying by 1/2 then will give me c is equal to 1/4. 1/2 times 1/2, so c is 1/4. So I get b is 1/2, c is 1/4. And then all we have to do is put those values in for b and for c. Put a 1/2 for b here, a 1/4 for c here in this third equation. We get 3/4 there. Take the minus a over to the other side, and we get a is equal to 3/4, 3/4. And that's your solution. A is 3/4, b is 1/2, and a is equal to 3/4. So we would just write it out this way. So your answer then would be x squared over x minus 1 squared times x plus 1 down here equals 2. And the a was 3/4. That's the numerator in this one. The b was 1/2, and the c was 1/4. Now you could rewrite it if you want to multiply this one by 4 and put this one as 3 over 4 times the denominator. You can write this with a 2, multiply by 2 here and put the 2 down here. Multiply this one by 4, put the 4 here, make that 1 over 4 times x plus 1. But this is an acceptable answer there. Now the other way that I'll point out is we could have done it this way, and you can, and these come out real nice, especially when you don't have any repeated factors, and when it's just first degree or linear factors, and none is repeated. So let's if I do it this way, again, same setup, multiply by the LCD on both sides. So this one will just give me x minus 1, and I'm just going to leave it factored out. Don't have to multiply it. Plus b, and again, this factor is going to cancel. It'll give me with b times x plus 1. And then multiplying the third factor over here, the third expression, the x plus 1 cancels. So this gives me c times x minus 1 squared. And so now, notice we can do this and say, okay, just leave it the way it is, and just, this is supposed to be an identity, so it's supposed to work for any number you pick. Let's say we pick x to be 1. Pick x to be 1, put a 1 where the x is. Notice x 1 minus 1 is 0. So this term completely cancels out. And what do I have left over here? Well, if I put a 1 there, that'll give me 2 times b, so this will be 2b. And put a 1 over here, 1 minus 1 gives me 0. That cancels out. And you have a 1 over here on the other side. 1 squared is 1. So I have 2b is equal to 1. So b is equal to 1/2. Which is what we got. So that b is equal to 1/2. Okay, so now let's say, well, let's suppose now that we want to pick now another number that'll make it easier. And I could pick a number, any number. I could pick x equal to 2, x equal to 3. And you'd get an expression involving some of these constants. But notice if I use the correct values, in this case, let's pick -1 now. Pick -1. So now, and for this first expression here, -1 and 1 is 0. So this cancels out. Notice this one. B, x plus 1, and if x is -1, that gives me -1 and 1 is 0 times b is 0. So what do I have left? Okay, over here I have c, and then -1 and minus 1 is a -2, and 2 squared is 4, so that gives me 4c. That has to equal whatever's on the other side. Well, -1 on the other side squared is 1, so I get 4c is equal to 1. So divide by 4, you get c is equal to 1/4. Okay, so that's what we got. Using the, writing the system out and solving, we're going to be equal to 1/2, c is equal to 1/4. And now if we want to get a out of this, let's get rid of this here. Okay, so now I want to use a number that will keep the value of a. So let's pick, you can pick 20, 30, 1/2, but we want to keep it simple. So let's pick something like 0. Let's pick 0. Put a 0 where the x is on this side. This is 0. Okay, put a 0 here. 0, 0, so it's -1 and 1. That's giving me a -a. And this is plus. And remember, we already know the value of b now. So let's just put a 1/2 there where the b is. And we're picking x to be 0, so that's 1 times b. And of course b is 1/2, so we got that. And then put a 0, we know c to be 1/4. So let's put a 1/4 with a, this will be 1/4. You see, 0 where the x is, 0 minus 1 is -1, but -1 squared is 1, so I get this. Add these up, we get 3/4. Take this over, we get a equal to 3/4. And of course, those are the answers we got. So there's short ways to do it that way. I'm emphasizing the system because, again, in college algebra, if you're doing calculus, you're going to be using this to find integrals. But if you're in algebra, the focus is going to be on systems. But there are other ways you can shorten the process, just to let you know about that. Thanks for watching. So again, the final answer for this one, of course, as I mentioned earlier, is this. This is your partial fraction decomposition. And this is the case again where the linear factors are repeated. Like I said, you can write this way or simplify by multiplying here by 4, multiplying here by 2, multiplying here by 4. That's it. Thanks for watching. We'll see you next time.